In this video, I'm going to show you how to run your first FLOSIC calculation using the FLOSIC software. The public release version of the FLOSIC software is available to download on the GitHub website. The URL is right here. And you can either use your web browser to download the software, or you can also use the Git to clone the source code onto your computer. Using the FLOSIC software, you can perform the Purdue-Zanger self-interaction correction calculation, PZSIC for short. The PZSIC is expressed with this energy expression, where you take deep DFA energy, the density functional approximated energy, and subtract the self-Hartree energy and self-exchange correlation energy for each and every occupied orbital I sigma. Now notice that those self-Hartree terms and self-exchange correlation terms are dependent on the orbital density rho of I sigma, which means depending on which rho of I sigma you use, you may get the different amount of the SIC energy. The goal of the PZSIC is find the set of local orbitals that minimize this total energy. In the traditional PZSIC approach, to achieve that goal, you solve this equation, also known as the localization equation or Peterson equation. If you find the set of local orbital phi I sigma that satisfy this equation, you essentially find the minimum total energy of the PZSIC equation. It turns out this localization equation is computationally expensive, and that leads to the FLOSIC. FLOSIC stands for Fermi loading orbital self-interaction correction. In the FLOSIC approach, you use Fermi loading orbital to solve PZSIC equations. Using the Fermi orbital descriptor positions, the FOD positions for short, you can transform the canonical orbital psi j into the set of the Fermi orbital f of I sigma, and by using the Lodin's orthogonalization scheme, you obtain the Fermi loading orbitals. By using the Fermi loading orbitals into the PZSIC equations, the FLOSIC approach transforms the problem into the following. Find the set of FODs that minimize the total energies. So the goal of the FLOSIC calculation is to find the optimum FODs or the best FODs that give you the minimum total energies. For that, you start with some initial guess of the FODs first, and then calculate the PZSIC total energy, and then calculate the FOD forces. FOD forces are the derivatives of the energy with respect to the FOD coordinate. And using the FOD forces, you can propose a new set of the FODs. And you repeat those steps until you find the best FOD positions or the minimum total energies.